Hi, Discrete Math students. Here's your first self-made video for your class. We are working on section 2.3 in the textbook. And in section 2.3, we are talking about Venn diagrams and set operations. And the first thing we're going to do is find a set's complement. And so just to review from what we did today, we can make up a universal set of any type of set. In our case, our universal set is the positive integer numbers from 1 all the way up to 9. And then our set A could be any other set that may have something to do with that universal set or not. But in our case, A is going to be the set of even numbers out of that set. So it contains 2, 4, 6, and 8. And what we want to do is we want to find the complement of set A. So that's how we read the notation. The complement of set A. So what is a complement? Well, a complement by definition is all the elements from the universal set that are not in set A. So the key word is not in set A. So you could say all X, the elements of the universal set, so that X is not in set A. And that's what the complement is. So what elements are not in set A but are in the universal set? Well, that's easy in our case. It's the odd digits between 1 and 9. And so this set would be the complement of A. So this is now an example. What I would like for you to do in this example is find B complement. So B complement will equal a set of what elements? And your job's to do that. So pause the video for a second and then see if you can figure it out, and then turn the video back on and see if you got it correct. So welcome back. Yeah, you can see that letters B, G, H are in set B. So the letters that are in the universal set but not in B are what's going to be a part of B complement. So you should have had A, C, D, E, F in your set B complement. If you did, then you did it correctly. So what we need to do is now find the intersection of two sets. So I have a simple example here. Set A is the elements A, G, H, and set B is the elements B, G, H. So we want to now find the intersection of sets A and B. So what is an intersection? Well, an intersection in easiest terms is where things overlap. Or formally, it would be A intersect B is equal to the set of all X such that X is an element of A and X is an element of B. Now what does that mean? Well, what I'm saying when I say X is an element of A and X is an element of B, what I mean is that they are elements in set A and B at the same time. And we can see in this example that the elements that are shared in each set are the elements G and H. Those are the overlap or the intersection of the two sets. So here's an example. I have a set A containing the elements A, G, H, a set C containing the elements B, C, D, E, F, and I want to find A intersects C. So what I want to look for is to see if there are any elements from set A that are in set C or in vice versa. And so I look, is element A in the set C? The answer is no. What about element G? The answer is no. What about element H? The answer is no. So, and then when I look, B, C, D, E, F are not in A as well, and so that means that there are no elements in common or overlapping between the two sets. There is no element X that is both an element of A and an element of C at the same time. Therefore, the intersection of our two sets is the empty set. So, I will then do another example, and we'll talk about what's called union, and I'll give you your homework. So, the last concept for this video is the union of two sets. So, we have two sets, A and B, as we did for intersection. What's the union? Well, the union is what I like to say, everything together. And what does that mean? More formally, we would say A union B equals the set of all X such that X is an element of A or X is an element of B. And what does that mean? Well, that means that if we have an element of A, it's in the union, or if we have an element of B, it's also in the union. So it's not about overlap, it's just about whether we have the elements or not, and if we do, they're in the union. So for example, what's A union B going to be? Well, I notice I have an element A, an element G, and an element H in set A, so those are going to be in the union, so I can put A, G, H. And then I also know that I have the elements B, G, and H in set B. Well, I've already listed G and H, so I don't need to list them again, but I have not listed element B, so I can list that. And so A union B is the set containing A, G, H, B, or everything together from both sets. So for this final part of the video, I have a few problems for you to practice. I specifically want you to practice problem 2 below on union, which is what we just talked about. There's an intersection and a complement, and then there are also some other problems listed over on the side. And so the challenge is for you to try and work through each of these problems, see if you can do them based on what we've done, and then 4 and 5 are kind of the challenge problems. And we'll look at what the answers are as soon as you come back to the video. Okay, the answers are B intersects C. Well, B has elements B, G, H, and the only element it has in common with C is the element B. So the intersection is just the set containing B. Now, how about B union C? Well, that's everything together, or everything in both sets. So it looks like we have B in both sets, then C, D, E, F, and then we have also G and H. So B union C is B, C, D, E, F, G, and H. C complement has B, C, D, E, and F, and so the complement of that is going to, if you look at the universal set, is going to be the elements A, G, and H, which is also equal to set A. So C complement and set A, not only are they equivalent because they are the same size, but they're equal because they contain the same elements. Finally, number 4 is B union C complement. Well, fortunately, we have just found C complement. It has a GH. So if we take set B, what's the union of that set with set C complement? Well, they both have GH, so we just need the other two elements, A and B. So it would be ABGH for the union. And then finally, the last problem is B intersects C in parentheses complement. Well, we have also found B intersects C right there, and it is just the element B. So what's the complement of that going to be? Well, it's everything else in the universal set. So that would be A, C, D, E, F, G, and H. Everything but the element B. So if you got all 5 of those right, you got a pretty good feel for how to do this. And tell you that all you need to do is, for your homework, and I'll tell you this now and we can go over it when you come back to class, but for your homework, I want you to do problems on 2.3. I'm going to want you to do problems 9 through 12. And then we're also going to do problems 18 through 39, multiples of 3. And finally, then we can look at some Venn diagrams, but we'll pick that up tomorrow. So this will be enough for today. So thanks a lot, and enjoy the video.